Okay, welcome to the Dublin Academy. My name is Mick Dalton and we're doing, I'm on YouTube and Facebook. You'll find me on Facebook on Dublin Academy and the same as YouTube. Now today we're going to look at squares and the sum of two squares, the difference of two squares. Okay, so this side here, I want you to freeze and take all of these two questions. Leaving Cert Ordinary Level Maths 2008, 2010 and they're paper 1. Okay, so we're doing paper 1 and questions, it ranges between questions 2 and 3. Now we have to find the values of x for which satisfy this equation. Okay, 22, 2 times 3, it's fairly simple. Now factorize this, okay, it all equals to 0. So in this case you'll have to use the formula, I think, in this one. No, you won't. Okay. Now it says using this, using what you've got here, simplify this. Well, you've got the factors of this, you can pop them in there. But there's something happening here. You have to get rid of this square root sign, and the only way to get rid of that is to square everything. Okay, and it'll relieve a lot of things. But you have an answer from there which carries into here. Now this is 2008. You have the papers, I'm sure. Now, and the next one is, given that x is greater than or equal to 0, solve for x. So there you are. So whatever solution you get here, you can put it in here. You don't have to do it all over again and make it equal to x squared. It looks like a quadratic function. This doesn't look like a quadratic. Maybe it might be. I don't know. Anyway, so copy those questions and practice, practice, practice. There's 14 questions here. These are all to do with factors. So they're very good for helping you master algebra equations. So here we are, today's series 1 and we're on episode 6, and today I'm just going to show you the difference of two squares and sum of two cubes, and I'm going to do some other interesting questions. But first of all, the difference of two squares, right, this is factors again, and this is the template that they follow. So what does that mean to you? It means that if I have any similar factors, squares, I can factorize it out like this. It's the first term minus the second term times the first term plus the second term. For example, I have one here. Say for example, we have one here, 4x squared minus 5y squared. Now, as you know, things don't get simpler, they get much more difficult. So I have to take out, there's no way, I cannot get 45 as a square root, so I have to factorize 5 here. So that means I have to take out 5. So if I take out 5, it'd be 5 times 9x squared minus y squared, because 5 times 1 is 5. And make sure you keep the signs. So now I've got this equation. So I use this equation, this template here. So that's our solution to that. So now we've got something else. Now, and I'm following this template. So that's 5 times still times the first term minus the second term. But first of all, 9x squared isn't fully squared. It has to be the whole entity. So the square root of 9 is 3. Okay? So it's 3 all to be squared. Right? Right, that's fine enough. Just remember that one. Okay, so it's the first term minus the second term, so it's 3x minus y. We don't put in any of the squares or anything like that. We just follow this template here. Okay, plus the first one plus the second one, so it's 3x plus y. All times 5. Okay, and that's that. That's that previous question. That's that question simplified. This is the simplification of it. It's factorized. Okay. So that's the difference of two squares. Now we have another one called the difference of two cubes. And in this case, the difference of two cubes is x minus y, the minus comes first, times square of this plus the product of them plus y squared. It's a matter of learning them off. Okay, so it's first squared plus the product of them plus the y squared. And you have to follow the signs that they're giving you. Okay, so this is a template. Alright. So when you're having, so for example, let's do, here's a very good one to do, to remember, 25a cubed. Now 1 can be 1 squared or 1 cubed, or any indice you can choose possible, because 1 by itself is always going to be 1. So we're going to give 1, as we're doing cubes here, because I can see the cube there. Now 125, I look at my calculator and I get the 125, the cubed root of it, which is equal to 5. If you don't know it, you will look it up. 5a all to be cubed. You see now what I'm doing? I'm getting the whole entity again, and it has all to be cubed. And I follow the procedure again. So it's the first minus the second. So it's 1 minus 5a. Times the first squared, which is 1 squared, which is 1. Plus 5a times 1, which is 5a. Plus y squared, which is 5a to be squared, which is 25a squared. And that's the answer to that. And this is this factorized. It doesn't look simple, but it is factors. If you multiply that by all of that and that by all of that, you will eventually get back to this. This is the whole point of factors and roots and solutions. So now there's a third factor, and it's a third one, and it's the sum of two cubes. And it's x plus y by x squared minus xy plus y squared. So as you can see, the signs just change in two of them, right? So they just change. There are opposites, as you can see. So you just write these out and practice them and learn them, because you don't have to do papers. So is it necessary for me to do a question of that? I don't think so for the moment. There's nothing that strikes me. So do these questions here, and you will. Maybe I'll do one of these here. This one here is a difficult one. X to the power of 4 plus 1. Now, how am I going to solve that? This is a kind of a difficult one. Okay. So I know that x to the power of 4 is also the same as x to the power of, and 1 can be to the power of it as well, as squared. And I see what I've done here, because I've done interstate roads here. I've broken this power into x squared times x, that group, times that group. X squared by x squared. That's all it is. It's commutative properties. So I just follow the same. This is minus, sorry. So I just follow the same. I use my difference of two pairs. So it's the first minus the second. Well, this is the first minus the second. Cheapers, minus 1. Times the first plus the second. And that's that, factorized. So you can see that we have these little subgroups in these powers. You can make them up. But anyway, moving along, and do those questions, attempt them all, try and attempt the answers. I will look at them, and I will, if you have any problems, as you know, I have nights, video nights that are, I will reply in some way. I'll send you a video, or I have a list of the questions done, and we will do the math. And any problems that occur in the maths papers. So we're still doing the paper 1, and I'm going to show you how to do this question. So this is question 3A, paper 1, 2006. Now the range is always questions 2 and 3. Okay, so this is question. I'll change this. This is question 3A. 3A, paper 1. Okay, so 3A, question 1. So it says find AB minus C over 2, where A is equal to 3, B is equal to 2 over 3, and C is equal to 1. Now I'm looking at this question here, and I'm saying to myself, what am I going to do? I have to put these fractions in. Now you know that these fractions, you have to know how to work these fractions. So I'm multiplying here, so remember I'm multiplying. So I just slot them in, 3 over 1 times B, 2 over 3, minus C, which is 1, all over 2. Now, when I'm multiplying fractions, I multiply the top by the top and the bottom by the bottom. Know how to multiply fractions. Look over your, when you're in primary cert, you know how to follow the code. It is a code. So we've got 2.3 by 2, which is 6 over 3. 6 over 3 is 2. 2 minus 1 over 2. 2 minus 2 is 1 over 2, which is a half. Okay? It couldn't be that difficult. Any more difficult. So you just get the habit of solving these questions and then doing them. And we're going to move on to the next question. C is x is equal to 3 plus 2x all over x minus 2. So x is equal to this. Change these colours so I can read them. X is equal to that. So I know that solving these equations I must multiply across by the LCM. The LCM is the lowest common multiple, and in this case it happens to be x minus 2. Well, x minus 2 is the same as fractions again, and it's the same as bringing them across. Is division bringing across becomes multiplication. So you see I'm bringing this across and I'm multiplying everything by the LCM, which is x minus 2. Now x has an LCM 1, but we don't include it because it doesn't make any difference to it. So it's still x minus 2 by 3 plus 2x, but that's going to cancel once I get this. But you must get in the habit of doing all this along, of everything, so you can check everything. So it's x minus 2, I know, so I'm going to cancel this. So I have to multiply this out. X squared minus 2x is equal to 3 plus 2x. There's nothing there, so I just open the brackets. And I'm left with x squared. I bring the x's together. X comes over and becomes minus 2x. So minus 2x minus 2x. Bring 3 over becomes minus 3 is equal to 0. So I'm going to x squared minus 4x, add the like signs, and add like signs, add and keep the sign. And I've got a quadratic here. So what am I going to do with this quadratic? Right, okay, so we've got it says give your solution in the form of a, x squared, what's that, minus 3, of a plus or minus square root b. Now what does that mean? Okay, it means that this solution here is not obvious. Okay, so factors of minus 3 when added give you is 1 by minus 3 or minus 1 by 3, and none of them add to give me 4. This one adds to give me 4. No, we're looking at 4 here. None of those add to give me 4, right? So so I have to use the formula. Okay, so the formula A is equal to 1, B is equal to minus 4, and C is equal to minus 3. So I use the formula. X is equal to minus B plus or minus the square root of B squared minus 4AC all over 2A. And I slot them in. Minus B is minus 4, so it's going to be minus 4 plus or minus. B squared is minus 4 to be squared, minus 4 times A, which is 1, times C, which is minus 3, all over 2 times 1. Okay, minus 4, I'm just checking this, minus 4 times A, C. Okay, now, so I'm looking at this minus by minus, so x is equal to plus 4 plus or minus, that's 16, a minus by a minus is a plus. Okay, any numbers or integers that are to the power of minus are to have a minus sign under squared is a plus, because you just make it out. Minus 4 by minus 4 is equal to plus 16, but it's a plus. Okay, so we've got, so this is 16. And this is minus 4 times, so this is 16 plus 12 all over 2. Alright, now I'm going to leave this to you. You get your solution. So it's going to be x is equal to 4 plus root 16, so that's 16, that's 36 over 2, all over 2, remember? So it's x is equal to 4 plus or minus 4 plus 6 over 2, or 4 minus 6 all over 2. Now you can solve that, okay? Because I have to go on and do another question. No, we'll leave it at that. So, is there any substitution? Any other question I'm going to put on here? No. So remember that. So when you have fractions, you multiply across the top. That seems to have gone so well. Okay, so that was that question done, and then I showed you the factors. So when you get your solution set, it says that's the way it says solve for give your solution. So that is the solution. Okay, and Or you can leave it, it says leave the solution in the form of a plus root b. Now they're being smart here now, you just leave it as that. You just leave it as 4 plus or minus root 36 over 2. Now as for plus, so you just include the plus part, because it's 4 minus 6, okay? And because they asked for a plus b. Well, actually no, we will not say that. We'll include the other term. But that looks okay. That's in that form. The two forms you're given. Anyway, thank you and good luck.